All right, diving right in. Today, we're tackling interaction diagrams in software engineering. You know, those visual representations of how objects in a system talk to each other, especially sequence diagrams.
Yeah, and we'll be using our software engineering lecture notes, the IT 2020 part 2.
Focusing on how these diagrams manage complexity using something called interaction fragments.
Right. Our goal today is to help you guys see how these fragments can really make even the most complicated system behaviors crystal clear.
So you can quickly see how all the pieces fit together.
Exactly.
So to get us started, interaction diagrams, what are they all about?
Well, they're these visual representations of objects, how they relate, focusing on the messages they exchange.
Right.
And then to manage that complexity, that's where these interaction fragments come in.
Okay, so interaction fragments, what are they exactly?
Well, the cool thing is they're basically like mini diagrams inside the bigger sequence diagram, and they let us represent all these different kinds of logic like choices or, repetitions in a structured way. So it's like adding these focused details to specific parts of the interaction.
Okay, so it's like a way to keep that main diagram clean while still showing all the nitty-gritty details.
Exactly.
So if you're looking at these diagrams, what are the big advantages? What does it do for you?
Well, if we zoom out a little, these fragments make sequence diagrams so much more powerful
Right.
because you can model those more intricate scenarios with different possibilities and flows of control,
Okay.
but you can still keep the overall view, understandable.
All right, cool. So let's get into some of the specific types.
That's good.
Let's start with ref, the reference fragment.
Sure.
What's that all about?
So the ref fragment, it's really helpful when you're dealing with these massive diagrams.
Mm-hmm.
It lets you just point to another separate sequence diagram.
Uh-huh.
So if you've got like a common interaction, like say select blog account type,
Okay.
you just define it once and then you reference it in other diagrams.
I see.
This makes your designs way more modular and easier to reuse.
Yeah.
You don't have to redraw the same interactions over and over again.
Right, like that activity 01 login example,
Yeah.
being reusable, this
Exactly.
saves you a ton of time.
Absolutely.
Okay, so it's all about keeping things organized and efficient.
Yep.
Now, what about alternative?
So the alt fragment, it's all about choices.
Okay.
It lets you represent these mutually exclusive options based on conditions.
Okay.
So for instance, in a login process, like in activity 02, you might have one alternative for valid login,
Oh.
which leads to a success message,
Right.
and another one for invalid login,
Yeah.
which prompts the user to retry.
Makes sense.
And so only one of those paths would actually be taken.
Right, right.
So when you're modeling a decision point with these clear, distinct outcomes, alt is what you would use.
Okay, so alt is like the either or.
Exactly.
What about opt, optional?
Okay, so opt, as you might guess, stands for optional. It's for these scenarios where an interaction might happen based on a condition.
Okay.
So if that condition is true, then the steps inside that opt fragment, they're executed.
Oh, well,
Otherwise, they're skipped entirely.
makes sense.
It's like an activity 03, like booking a movie ticket, but only if there are seats available.
Right, right. It's like if this, then that.
Exactly.
Now, loop, I'm guessing that handles repetition.
Yeah, loop is all about modeling sequences that repeat based on some condition.
Okay.
And you can even say, how many times that loop should run, at least and at most.
Oh,
Like in that activity 04 example, where a customer is making multiple ticket requests.
makes sense.
It's super helpful for visualizing any kind of iterative process.
And break, that sounds kind of like an exit strategy.
Yeah, break indicates a point where if a certain condition is met, then the rest of that enclosing sequence is abandoned.
Oh.
It's often used for like modeling error handling or these exceptional situations
Right.
where you need to jump out of that normal flow.
Okay, and finally we have par for parallel.
Right.
How does that work, like visually?
So par signifies concurrent execution.
Okay.
So it shows that different interactions within those regions of the par fragment can happen at the same time.
Right.
The order within each region is maintained,
Okay.
but the regions themselves can overlap in time.
Gotcha.
A good example from the notes is that search engine on pages 19 and 20, where searching multiple databases could happen concurrently.
Right, so you're doing a bunch of stuff all at the same time.
Exactly, and that's really important when you're visualizing systems where multiple things can be happening at once.
Right. So it sounds like all these interaction fragments give you a really structured way to visualize all these different complex behaviors within a system,
You bet.
and making them much easier to understand and to design.
Yeah, they let you move beyond just the simple linear flows and model more realistic and complex interactions.
But still in that clear, organized way. So the big takeaway here is that these interaction fragments are powerful tools that give you a shortcut to understanding complex software interactions in a really organized manner.
Yeah, and it makes you think, how could these concepts of optional, alternative, and parallel processes apply not only to software, but to real-world situations and decisions you make every day?
Mm.
What other complex interactions could you visualize using similar structured approaches?
Yeah, that's something to think about.
Of course, if you want more detail, you can always check out the references on page 21 of the notes.
Absolutely. Well, thank you so much for joining us on the deep dive today.
It was a pleasure.
And thank you all for listening.
Until next time.
See ya.